All right, guys, I guess we're getting ready to take a look at the second topic in Chapter 9. And today we're going to be talking about the equation of the line of best fit. All right, so I know that sometimes things get a little confusing when there's more than one name for the same thing, but that is going to be the case here. So if they ask you to find the equation of the line of best fit, all right, that's the same as if they ask you to perform a linear regression, because the results of linear regression, all right, is an equation of line of best fit. And also, if they ask you for the least squares line, right, they're asking you for the equation of the line of best fit. Okay, so three names, same thing. I know it gets a little bit confusing. All right, and the other thing that we need to kind of be careful of here is you gotta change your thinking. We're used to y equals mx plus b, all right, from algebra. But in stats, we use the y hat equals a plus bx. It's the same idea. The only thing is that b is the slope and a is the y-intercept. But this is the form that we use. All right, a is the y-intercept. A is the y when x is 0. All right, and b is the slope of the line. Okay, so when you're finding the y-intercept, the formula is a equals y bar minus b times x bar. So to find a, you need b first, so we always use b first. So taking a look at this equation, all right, it's very similar to what we used in R, except it doesn't include everything. All right, so we're going to be using a lot of the same information that we did before. All right, so first of all, right, we find b, all right, which is the slope, all right, and then we find a, which is the y-intercept. All right, now y bar is just the average of the y's, and x bar is the average of the x's. All right, so using our data, we don't need x bar for this, so I'm going to cross that one off. It'd be nice if you get a question, you just cross some stuff off, and you don't really want to do that. Yeah, sorry. You have to know what you can cross off and what you can't. All right, so stat edit. All right, I'm going to clear the data that I have. All right, and I'm going to put this data in from the question. Let me zoom in on that a little bit because this is a little blurry. And this thing I think is the focus. See if it helps any. Yeah, a little bit. All right. So my x's go in list 1. And my y's go in list 2. Okay. All right, so the formula, let me write that down again just to make sure I don't do anything extra here. So b is the sum of xy minus the sum of x times the sum of y over n over the sum of x squareds minus the sum of x's squared over n. All right, so I need xy and I need the x squareds. All right, so if you remember how we did that in the first lesson, go up to the title for list 3, and I need x squared, so I'm going to do L1 squared. Uh-oh, wrong button. All right, and those are all of my x's squared. 1156, 729, 625, 289, 529, and 400. All right, and then I need my xy's. So I'm going to go over to list 4, go up to the title, and do L1 times L2. Okay, so 1980, 2686, 1890, 1500, 816, 1265, and 1200. All right, so then I need the sum of all those columns. So stat, calculate one variable stats on list 1. All right, the sum of x's is 176. And the sum of x squareds is 4629. All right, so now I need to do one variable stats on list 2. And the sum of x's is 438. And I don't need the sum of y squareds. All right, so now I need the sum of xy. So stat, calc, one variable stats. I think I did that on list 3. I hope so. And the sum of x's, that 4628 does not look right. Let me go back, stat edit. Oh, that's in list 4. Yep. List 4. Okay, so stat, calc, one variable stats, list 4. It's always important to think about what your calculator is telling you and see if it makes sense. If it doesn't make sense, all right, then you got to go back. So if you notice, this couldn't have a sum of 4,000 when I've got these two numbers right at the beginning. That's already more than 4,000. So I knew that that wasn't right. I had done something wrong. All right, so B is the sum of xy, 1137. Whoop, 11337. Sneak that other 3 in there. Minus 176 times 438 over n. 1, 2, 3, 4, 5, 6, 7. We got 7 pairs of numbers, which makes n 7. All right, the sum of x squared, 4629 minus 176 squared over 7. All right, now this does not give you that information from the calculator or from the one variable stats. So I need to do that calculation. All right, so get out of here. And then alpha y equals enter to get a fraction, 11337 minus alpha y equals enter, 176 times 438 over 7, and down to the denominator, 4629 minus a fraction, 176 squared over 7. Okay, oh no. So 2271 divided by 1427. So 1.591. Okay. I'm remembering that being a different number, so I've got to check and see. I might have done something wrong here. But we'll take a look. We'll take a look and see. What about that 438? Stat, calc, and variable stats on list 2. All right, and then A from our equation on the other side, all right, is y bar minus B times x bar. All right, so the average of the y's, 438 divided by 7, is 62.571 minus B, 1.591 times x bar, 176 divided by 7, is 25.143. All right, which gives us 62.571 minus 1.591 times 25.143. 22.568. All right, and then y hat equals a plus bx. Y hat equals a, which is 22.568 plus 1.591x. All right, so this is the answer to the question when they ask you to find the least squares line, find the equation of the line of best fit, or do a linear regression. All right, so now that's the process that you do when you are asked to do it by hand. All right, so let me just check those numbers because like I said, I remembered that answer being something a little bit different. And I wonder if I did something wrong. But you see the process anyway. Okay, so using the calculator to find, all right, the line of best fit. So if they don't ask you to do it by hand, all right, you can use the calculator. But remember I asked you guys who have had me before, all right, is to break that down into pieces. Don't write down just the answer. All right, so looking at my data, it's in list 1 and list 2. So stat, over to calculate, down to the a plus bx, not the ax plus b. All right, and my second one, my x's are in list 1. My y's are in list 2. There is no frequency list. We're not going to store it. So get down to calculate. All right, and yeah, I knew that was off a little bit. All right, A is 22.361. Now I got to go back and figure out where my mistake is. 1.599. But I'll do that after I turn the camera off. So you can always check your answers and make sure that they are correct. All right, if you go through that whole process and you just have one number off, you're going to lose a point out of 20. So not a big deal. Yeah, I know. Some are greedy. Want them all. So 22.361, it's my y-intercept, plus 1.599x, which is my slope, times 1.599 is the slope, times x. All right, and then the only other thing we're going to have to do with these equations is to make a prediction. Okay, so when we make predictions, all right, there's something called interpolation, right, which is using an x value in the interval of x values given in the table. This is a good thing, all right? This is okay. So we're predicting y using an x that's in our interval of numbers. Now our interval of numbers here goes from 17 to 34. All right, if I was asking you to use 31 as a predictor, right, that would be okay. That's interpolation. But if I ask you to use 50, right, that's a problem. That's a danger because these numbers used to predict y went from 17 to 34. I'm not convinced that that pattern is going to continue. all right, indefinitely. Now, I may have already talked to you about this, but I guess saying it twice is better than not at all. I like to think of the two variables. One of them is time spent studying for an exam, and the response variable, or the y, is the score you get on the exam. Now, to a certain point, if you study more, you're going to do better, right? But there's going to come a time when either your brain is full and it's just fried and it's not going to take on any information right now, all right? Or you know the material. So we're not saying, or we can't say, that that pattern will continue indefinitely. Right? There's going to come a point where it starts to level off. All right. So that's where extrapolation comes in. Extrapolation is using an x value not in the interval of x values given in the table to predict y. Right? This is dangerous. We're going to be careful of extrapolation because we have nothing in our experience that's going to say this pattern will continue. We can't guarantee it. It might, right? But we can't guarantee it, right? So if R is strong, we can get a good prediction as well, right? But if R is moderate or weak, the prediction should not be trusted. So two things to be careful of when making predictions. Number one is extrapolation, right? That's using an x value that's not in the interval of x's we use to get the equation. All right, and then the other thing to be careful of is a moderate or weak correlation. Now, a few years ago, they were asking us to predict at the beginning of the year what a student is going to do at the end of the year. All right, that's an extremely dangerous thing. So I thought, hey, I teach stats. I ought to be able to come up with something that will be, accurate and a good predictor. Well, I tried the previous year's geometry regions exam to see if that would predict an Algebra 2 score. And my correlation was really bad. So I thought, well, algebra is algebra, geometry is geometry, maybe, and the Algebra 1 score would be a good predictor of your Algebra 2 score as far as regions is concerned. And that didn't work very well either. That had a very poor correlation. So there was really no sense of me trying to use either one of those because I wasn't going to get a good predictor. All right, so going back to our equation here, y hat equals a plus bx, 22 point, I want to say 361. Hey, how about that? Plus 1.599x. See, I've got that magic whiteout tape at home too. All right, so use the equation of the line of best fit from the data shown to predict y. All right, we're predicting y when x is 28. All right, so all you do is put 28 in place of the x. $22.361 plus 1.599 times 28. Okay, so we didn't actually get information that went with this data. So I don't know what the response variable is. I don't know what the dependent variable is, but y would be 67.133 or approximately when x is 28. Right? This is interpolation. This is okay. Use the equation of the line of best fit from the data above to predict y when x is 50. Right? This is extrapolation because in our question, right, my x values only went up to 34. I'm not guaranteed that this pattern will continue all the way to 50. Right? So this is a dangerous process, but it can still be I can still do the math. I just don't know that I can rely on the result. All right, so I'm going to go back up and get that data, or that equation, change the 28 to a 50, and my prediction is 102.311. Okay, so coming up with a line of best fit. Remember, if it doesn't say to do it by hand, you don't have to do it by hand. And if it, you can use the calculator, right, and also making predictions using that equation of the line. All right, so that's it. We just have one more video to finish up chapter 9, and I will get that one to you soon. Have a great day.